One thing I did promise you was that I would show you how you would do this using group by key instead. If you're not interested in that, and if you've had enough, then feel free to end this video and you can move on to the next one. I'm really doing this just for completeness, and I don't use group by key very often because, as I mentioned, in production clustered systems, group by key can be very problematic, and I'll be explaining why that's the case later on in the chapter on performance. But I'll just temporarily copy this section and comment it out. I'm going to leave both versions in here just so they're available in the Practicals and Code folder. And I'm going to tweak this then. So we've mapped to a pair. Now it doesn't really matter what we have in the values, so I'll leave the ones in place. But just to show you, if I go back to here, instead of reducing by key, we can do group by key. So that's going to give us this pair RDD with the values in a list. Now, because I've not restored the date and time as the values, we're just going to get a list of ones. But that's all we need for this example. So we just need to count up the ones. Now, as I mentioned, the really awkward thing about this is the iterable just doesn't have a size method available on it. So we can loop around that iterable and count up the values. But now I must admit, I didn't know a clever way of getting the size of an iterable in Java. I just knew that you'd probably have to loop around all the values and count up a sum, which seems very awkward to me. So I've had a look on Stack Overflow and I've actually found there are a good couple of suggestions. You can use the Guava library, which is sort of Google's extension to Java, where they've added lots of useful classes. And you can call a very simple method iterables.size, passing in your iterable object, and that will give you the size of the collection. So that's one way of doing it. And another way, there is from Java 8 onwards, you can call this splitterator method, followed by get exact size if known. Now, that doesn't look very intuitive to me, I must admit. I think out of the two of them, I personally prefer this Guava version. And we're very lucky because, in fact, we do have, and just test this out, it just so happens that we do have on our class path, I'm just using the IntelliSense there, if I do iterables dot, we have got the Guava libraries available on our class path because they were transitive dependencies of Apache Spark. So obviously Apache Spark is using Guava, so we can do the same. So that means once we've called group by key, what I could do, I can finish off by doing a for each. That's going to give us, for each value will be a key value pair. The value will be this iterable, and we want to know the size of it. So each of these will be a tuple, and we can pass that to system.out.println. And I'm just copying the format I had here. So we've got tuple._1. That's going to be the logging level. And we want to count up how many instances it has. Well, this time the tuple._2 is going to be this iterable object. Well, we know now we can pass this into the iterables.size, pass that in, and that allows us to count how many instances there are in that iterable. And I've missed a round bracket off the end there to close the for each. This doesn't feel very intuitive to me. Together with the fact that group by key, I haven't said why, but it's not performant. It will cause crashes if you've got any kind of big data. I will be explaining why that's the case, but for that reason, I very, very rarely use group by key when I'm working with Spark. So I've only put this in here just for completeness. And if you ever hit this problem of counting up an iterables, maybe that's useful to you. Let's just check that the output's the same as it was before. That looks correct, but definitely problematic code. I would definitely recommend that you go for the reduce by key method. instead of group by key wherever you can. It's nicer and it will perform better.